Today's lesson is 3.1, and what we're going to talk about today is we're going to be solving, all right, system of equations. So we're going to be solving systems of equations, and we're going to be doing it today by graph, okay? Now, remember, here's what's going on, okay? System of equations, all right, they consist of two variables. So systems of equations, normally they go ahead and they have an x and a y variable, okay? And normally what happens is, so you got your x and your y, or you have two variables, okay? And it also consists of two equations. All right, so if you take a look at example number 1 right here, all right, this one right here is a system of equations because you have this equation and you also have this equation right here, okay? And both of these equations have two variables in them. This has got an x and a y, and this has an x and a y, okay? Now, ways to solve these things, what happens is to get a solution to these things, pretty much what we're looking at is a solution is going to be an ordered pair. All right, it's going to be an x and a y, because what happens is the solution to these systems is really where these things go ahead and intersect, where the graphs intersect at. So the graphs go ahead and intersect. That's what we're looking for. Okay, so to solve these things, you know that the system of equations, they have two variables, x and y. They consist of two equations, and what we're looking for is we're looking where the graphs go ahead and intersect, and that's going to be our solution in ordered pair. Okay, so for example number 1 right here, you're always going to start off with your b value and your m value. So your b value right here is a plus 4. So you know that your ordered pair is going to be 0, 4. And your m value is rise of 3, run of 2. So I'd go ahead and I'd graph that one in order to go ahead and solve it. So I'm going to go up to 4. And then I have a 3 and a 2. But if I go up 3, I'm off the graph. So I'm going to go down 3, which means I'm going to go to the left 2. All right, down 3. And I'm going to go to the left 2. Now I'm going to draw in my first line. Okay, here's my blue line. My purple line, my b value is 0, 2. My ordered pair is 0, 2. The b is y-intercept is 2. And your m value here is 1 over 2. So I'm going to go up to 2. And then my m value is rise 1, run 2. Rise 1, run 2. Or I could go down 1 over 2. Look what just happened there. Down 1 over 2. It looks as if my blue line and my purple line intersect at this point right here. All right, so my solution is going to be that ordered pair, which is my x and my y. So I have negative 2, and then I have up 1. So that right there is the solution to the systems of equations. Negative 2, 1. If we wanted to check this, we would substitute it in for my x and my y, and we go ahead and we make sure that it satisfies both equations. Okay, let's go ahead and let's try number 2 real quick. Okay, y is equal to 3. I'll call this one right here my green line, and then we'll go ahead and we'll do pink line right here. Okay, so to graph y equals 3, you know that that is going to be a horizontal line. Okay, that intersects at the y-axis. All right, my pink line now, my b value is equal to negative 2. So my ordered pair is going to be 0, negative 2. And my m value is equal to negative 5 over 4. Okay, so I'm going to go down to 0, negative 2. And then I have negative 5 over 4. But I can't go down 5. So I'm actually going to take this and turn it into 5, negative 4. I'm going to go up 5. 1, 2, 3, 4, 5. I'm going to go left 4. 1, 2, 3, 4. That's my negative. And I have constructed my second line here, and we can go ahead and find the point of intersection. My solution for this one is going to be negative 4, 3, because I go over 4, and then I go up 3. Okay? So that's what we're looking at in order to solve system of equations. You pretty much just go ahead and graph them and look for a point where they intersect at. Okay? Now, there's 2 special cases that I want to show you about. All right, so there are special cases. what happens is we sometimes might have something like this. I got my y-axis, I got my x-axis right here, okay, x and y. We might sometimes end up where we have a line that looks like this, and we have a line that looks like this. And let's say that this one right here, this blue one, is y equals 1/2 x plus 4. And this red one right here is y equals 1/2 x minus 3. All right. What you notice about these two lines is that they have exactly the same slope. So we know that these two lines right here are parallel, which means that they are never, ever, ever going to intersect. Okay? So if you have a special case like this where you have lines that are parallel and they're never going to intersect, we know that we have no solution. Okay? Then there's a special case that looks like this. Let me go ahead and move down a little bit. All right, I'm going to draw on my y-axis, and I'll draw on my x-axis. Let's say we have the equation of a line that is, I'll draw this in. All right, we'll say it's y equals 2x minus 1. Okay? And then we have the exact same line drawn on top of it. And the equation of that one is y equals 2x plus 1. These ones have the same slope. They have the same y-intercept. So if we wanted to talk about a solution, is that a solution? Is that a solution? Is that a solution? All right. Every single point on this line right here, all right, intersects with the other one. So this one right here, when you have two lines that are exactly the same line, all right, instead of saying no solution, this one says we have an infinite number of solutions. All right. So those are my special cases. If you go ahead and you intersect here, all right, you have one solution. If you go ahead and you have parallel lines, like we talked about over here, no solution. And then lines that are exactly the same have an infinite number of solutions. Okay? I don't think I really have to go through these. Let's go to the next page. I want to talk to you about these ones right here because these ones are not in the form of y equals mx plus b. So all we have to do is we have to take and we have to solve them. So for this one, you have 5x plus y is equal to -1. All I would do is I would subtract 5x like we've been doing all year, and I'd be left with y equals -5x minus 1. I graph the minus 1. I do my slope of down 5. 1, 2, 3, 4. Oh, so I'm going to go up 1, 2, 3, 4, 5, which means now if I went up 5, I got to use the negative. And I would graph this line. Okay, green line, x plus y is equal to 3. Subtract x, y is equal to -x plus 3. So find plus 3. Down 1 over 1, down 1 over 1. All right, down 1 over 1. So this one looks like we have an intersection point of this right here. Okay, now that one's a little tough, and that's why this is maybe not the best method sometimes to go ahead and solve. But this one looks like we got -0.5, and then we got 2.5 as my solution. All right. If you want to check that one, you can go on the calculator and check it. Like I said, not the most accurate graph right here, but if we wanted to check our answers, we would just go ahead and we'd put them right in here. And it doesn't look like I did it right. 1, 2, 3, 4, 5. -1, got up 3. Oh, you know what I did wrong? I know what I did wrong. Here's what I did wrong. All right. This green line right here. Let me go ahead and erase that. All right, I made a mistake here. This green line right here, I'm going to erase that. I'm going to go back to purple. All right, I'm going to go ahead and continue that. My green line, look at what I had. Up 3, I did down 1, left 1, which would have been positive. I should have gone down 1, right 1, down 1, right 1, or up 1, left 1. And now we have my point of intersection right here, and I have it at -1, comma 4. And if I substitute that in, what's -1 plus 4? End up with 3 there. Okay? That right there is pretty much graphing to solve system of equations. You just go ahead and find the point of intersection. And then remember, if you don't have a point of intersection, it follows one of these two special cases right here. All right? 3.2, we'll go ahead and we'll talk about solving systems by elimination and substitution.